All right, guys, let's go. All right, composition and inverses. There's a domain piece that you have to think about domain, but the other part really is very hard. You're getting better at domain. Some of it's very easy. Some of it. All right, guys. I can give you very wordy definitions of what composition means, but I think it's going to be easier if I just show you. So let's do find f of g of x. Okay, that does not say fog. That says f of g of x. Okay. Yeah. And g of f of x. So not goth. That's goth. And you are given f of x equals x squared plus 2x. You love these. It's so good. You've seen these before.
Yes.
Yeah.
They're not too bad. I just realized you just.
For the win.
I know.
Are you okay? You did this in algebra too, definitely.
It took me so long to understand it because I kept overcomplicating it, and then it clicked.
And then you're like, oh.
I'm not kidding. It was like 2 weeks, and then it finally came to me.
And you forget it, right? That's the factor.
Oh, unit factory. Someday you're gonna.
I mean, it just takes me a long time.
We will do more factoring before the year is done. So you will really do. It's never going away.
Yeah.
All right, guys. So the first one, we're gonna find f of g of x. What that means is we are taking the g function, so this x minus 4, and plugging it in over here, anywhere there's an x. It is open. It's like a teeny tiny little open. Guys, you may have seen it written like this last year too. Yeah. That means the same thing. Okay. Okay. I actually do too, but I want to make sure you see it. It does make more sense. Switch to that. Yes. Yes. All right, guys. So this one, does everybody understand the plugging in there that just happened? Okay. And then you just have to simplify. So x minus 4 squared, that's going to be x squared minus 8x plus 16 plus 2x minus 8. So we're left with x squared minus 6x plus 8. So that is f of g of x. Easy?
Wait, was it again?
No, I'm so good.
Well, I can do things like with fractions and square roots and ask you about the domain and all of that. But we are going to review a lot of stuff you saw in Algebra 2. We'll just go through it faster so that you actually understand it this year too. I feel like sometimes in Algebra 2 it's like, okay, I saw it and I passed the SOL and I don't have any idea what happened. So.
I don't know.
No, I think there's too much calculator usage in regular algebra 2. I think there's a lot of like learning how to do a calculator trick to pass the SOL instead of like learning the
Right now
math.
we can't pass it without our calculator.
You might have
But they don't do.
I think
We don't.
Yeah.
you doubt yourself. Okay, Steven, you had a question.
Oh no, I figured it out.
Okay. All right, guys. So we're good with the first one, right? So let's do that. So let's do the other one, the g of f of x, or if you like this way better. It could be either way. Okay. So guys, what is different about this one? What do we do on this one? Franz, what do I do?
I'm not really like that. I like where it's
So all of this goes into that one x. So is there really any work to do on this one? No. So we get x squared plus 2x minus 4. And you are done. So that's easy, right? Okay. I will ask you domain questions about these, which for this first one, they were very simple. If you look at the original ones, what's your domain for f of x?
All real numbers.
All real numbers, right? No fraction, no square root, so we're good.
Oh my god.
What's the domain for g of x? All real numbers, right? No fraction, no square roots. Okay. When you combine them, you have to look at the one you plugged in first, and then you look at your final answer. So those were both all real numbers, so we're good there. What about what your final answer is here? Okay, what about this one? The domain of everything in this problem is all real numbers, okay? So that's a very simple one. We will get into ones that are a little more complicated than that. But questions so far? So far, so good? All right. You guys are safe. All right, you're going to find f of g of x. And we'll do both of them, g of f of x. We won't always do both of them, but... That's an and, sorry. No, look at the symbol. So before we start anything, I want to talk about domain again. So domain of, let's do g of x first, because that one's easy. All real numbers, okay. All right, what about the domain of f of x? So, and you can write it out formally, or if you just want to make a note to yourself, like, hey, I know it can't equal 1. Like, that's what you need to be thinking about. So when we go through the problem here, like on the first one, when I do f of g of x is the function that I'm plugging into the other one, right? You have to start with the domain of g of x. So what was the domain of g of x? All real numbers, so that's easy. That doesn't really affect anything. So then we can go through and do the problem. So then we'd have x squared minus 1 over x squared minus 1 minus 1, right? So when I simplify that, I have x squared minus 1 over x squared minus 2. So the composition part is easy. Domain, we've got to think about a little bit here. We have a fraction, right? So what do we worry about with a fraction? The bottom. So that x squared minus 2, remember, that cannot equal 0. So what does that mean x cannot equal? Plus or minus square root of 2. Yeah, because if you solve that, you'd add 2 and then take the square root. So the way you write your domain, negative infinity to negative root 2, negative root 2 to root 2, and then root 2 to infinity. So that's the domain, and that is your f of g of x. That's a heavy sigh over there, Jimmy. Let me move it up for you.
For the first part, you said we have to look at what the domain of g of x is. If that's not on there,
Yes, so we're going to do the second one. We'll do g of f of x, right? So this time we have to look at the domain of f of x. Well, what did we know about the domain of f of x? So we got to keep remembering that the whole way through. We know right from the start x cannot equal 1. Okay? And then we have to plug our function in. So we would have x over x minus 1, quantity squared minus 1. Whoa. I love Mr. Berkeley. All right, so when you square this, you have x squared, and then you have over x squared minus 2x plus 1, and then we have this minus 1 over here. I don't remember, how mean do I want to be to you? We're going to leave it like that. Are you okay with that? So that's your g of f of x. All right. You absolutely could find a common denominator so that you could subtract the 1. We're not going to do that right now. We'll just work on the composition part. But then we have to think about the domain. So we know already from up above that x cannot equal 1. Look at your denominator here. X squared minus 2x plus 1. We just multiplied it out, so we know it should factor. What does it factor into? X minus 1, x minus 1. So what can x not equal from this? It's still 1, right? It's not always going to work out that it's the exact same thing as you had originally. Sometimes it is, okay? So the way you state your domain, negative infinity to 1, 1 to infinity. Okay? Are we doing okay so far? Yes, okay. Let's do, for sure, one more. All right, where am I on? All right, this time we're only going to find f of g of x. We're not going to do both. You are given f of x is x over 2x minus 1. Bless you. G of x is x minus 2 over x minus 1. The fact that they're both fractions to start with means it's going to be ugly, like it's just going to be messy algebra. Sure. Good, okay. So we're going to start with our domains of f of x and g of x. Just real quick, think about, are there any restrictions? So for f of x, we've got a fraction, right? What can x not equal? 1/2, right? What about g of x? What can x not equal? Okay. Since I'm finding f of g of x, which one of those do I actually care about? g of x, yes. So we need to remember this when we get to the end. Okay. All right, so I have to plug that entire fraction in anywhere I see an x in f of x. So that means I have x minus 2 over x minus 1 over 2 times x minus 2 over x minus 1 minus 1. Okay, that's nice, isn't it? We can simplify this. Are we okay with that, though? Everyone understands what's happened there? We're good? Okay. So, your numerator. We're leaving alone the x minus 2 over x minus 1, okay? Your denominator. We're multiplying that first fraction by 2. Remember, 2 is like 2 over 1, okay? So that's going to give me 2x minus 4 over x minus 1 minus, now I'd like that 1 to be something I could actually combine, so what do I have to look for? Common denominator. So I'm taking the 1 times x minus 1 over x minus 1. Okay. So I'm going to put it in parentheses. Each step of the way, I want to make sure you're with me, okay? Look at it all at once, it's very overwhelming, but baby steps, we'll get there. So are we okay to that point? Okay, and do you guys see now in the middle of this problem why x cannot equal 1? Like why that one matters? Like if you look at your fraction, that's not okay for x to be 1, that's not okay. You see it? Okay, so we can now do some simplifying. So I still have x minus 2 over x minus 1. But I can actually subtract these fractions. So what do I end up with there? What's this? X minus 3 over x minus 1. Okay, we're getting somewhere now. Yeah, fraction over a fraction we can flip and multiply. And before you multiply anything, what do you see? Yes, and that should happen every time you're doing one of these, okay? They should go away. So x minus 1s are gone. That all turned into just x minus 2 over x minus 3. So that is our f of g of x. Ugly but doable, right? No, Prom says no.
Would you subtract the x minus 1 and get x minus 3 minus x minus 1 minus x minus 1?
So think about it, you're just subtracting fractions. Like if I had like 3/5 minus 2/5, what is that? Yeah, you left the denominator alone, right? So that's why.
Oh.
No, it's just straight subtraction. So you're going to 2x minus x. Okay, so we've got our function. We now need to think about our domain. So for our domain, what did we need to remember from up above? What can x not equal? 1. And now looking at this fraction, what else can x not equal? 3. Everybody okay with that? We're getting faster with our domains. Okay. So the way you would write that, you could do the squiggly bracket x such that x is an element of the reals too, if you like that. I saw in your quizzes some of you like that better. But if you're doing the intervals, negative infinity to 1, 1 to 3, 3 to infinity. Okay. That's about as ugly as they get. I could add a square root for one of the f of x or g of x, but like that's the general idea. Find the domain, plug them in. Okay. All right. We are not quite done. We have inverses left, but that's it for composition. We're okay with that. After inverses, we will be. Well, you can start on your homework. Yeah. Yes. So guys, do you remember anything about inverses from last year? It is over the line, y equals x, yes. What else? What happens to your x's and your y's? You just change them, yes. So, if I asked you to just find the inverse, you would switch x and y and solve for y. That's probably what you did in Algebra 2 most of the time last year. Yes, that's familiar. What we are going to do is determine or prove so if or that, my next word doesn't make much sense, but f of x and g of x are inverses. So, the way you do that. So you're given, let's see, f of x equals 2x minus 6. G of x equals 1/2 x plus 3. The only way you can prove that they're inverses is by doing composition of functions, which is what we just did. No domain issues to figure out with it, though. You just have to do the composition. What you need to look for, you have to find f of g of x, and we have to find g of f of x. If they both end up being x, then they're inverses of each other. Not necessarily that they're just the same thing, but if they're both x, they're inverses. What?
Never mind.
You sure? So if you do the composition for the first one, like if you do f of g of x and you get anything other than x, you don't have to do the second one. You can say, no, they're not inverses, okay? But if the first one works out to be x, then you have to do the second one to see if it's also x. So let's try f of g of x. Okay, so remember that will be this all going in. So we would have 2 times 1/2 x plus 3, and then minus 6. And yes, you'd have to show your work the whole way through since you're proving it. So what's 2 times 1/2 if I distribute it? 1, so that's x. Okay, what's 2 times 3? Technically, you should also do the f of g of x, but I won't be picky on that. Okay. And then minus 6. So what does that simplify to? Okay. So that one was x, so now we have to go do the other one. So g of f of x. So we go the other way. So we have 1/2 times 2x minus 6 and plus 3. So when you distribute your half, what do you get? X minus 3 plus 3. So what is that? X. So you would say yes, f of x and g of x are inverses. Are we okay with that one? Yeah? Not bad? So let's do another one. Anybody questions on that one? Okay, so guys, you noticed how it was very organized. We did f of g of x, then we did g of f of x, and then you came to your conclusion. Okay, please do not give me like a jumbled up mess of compositions, okay? All right, let's try another one. You guys do this one. So we've got f of x is the square root of x minus 4. G of x is x squared minus 4. Okay, so I'm going to give you a second to do those. See what you think. Bless you. All right, guys, what do you think? Yes or no?
No.
No? Everyone in agreement? You are correct. Okay, you cannot simplify that to x, so you could stop there and say not inverses.
Because the parentheses are not.
Then it's not going to work. Yep. So that's the only thing you have to worry about. All right. We are also going to find the inverse, but these are pretty simple. This is what you did in Algebra 2. Find the inverse. So you are given f of x, and we'll even change it to y, equals 8x minus 3. To find the inverse, all you're doing is switching your x and y and solving for y. So you would start with x equals 8y minus 3. And then how do you solve for y? Yep. Okay. Easy enough. Let's see, do I have a trickier one to give you? I do. All right, last example, guys, okay? 2 sections in 1 day. Good work, guys. And we're going to do this one together because it's a little different. All right, so that's what you are given. Y equals x plus 6 over x plus 3. So what's our first step if we're finding the inverse? Okay, so you have x equals y plus 6 over y plus 3. Most people are very good at that, and then they kind of get stuck. Okay? So the way you move on from here, I don't want that y plus 3 in the denominator. So how do I get it out of the denominator? Okay. So that means the left side of my equation, when I distribute, I have xy plus 3x. All that's left on the right side is y plus 6. Okay, we're closer, but we're not there yet. This is where you have to remind yourself, what variable are we solving for? Y. So I want everything with a y on one side and everything without a y on the other side. So I'm going to leave my xy there. I'm going to bring over the y from the other side. Over here, I'm going to leave the 6 alone and bring over the 3x. So take a second, look at that, make sure that makes sense. You with me still? Okay. Okay, what can I factor out on the left? A y. It should be what you're trying to solve for, okay? So factor out a y. What do I have left in parentheses? X minus 1. So what do you think my final answer of y equals is going to be? Good. 6 minus 3x over x minus 1. That is your inverse of the original function. Try to scroll it up a little for you there. Yes, please.
Minus 6 and then minus 6y, and then looking at 2x minus 6.
Let me see what you're saying. Yes, if all your signs are opposite, that's totally fine. Yeah. You still got the y by itself on one side. Yeah, you just had it on the other side. That's okay. All right, guys, questions? Okay, so let's look at your homework.